Hello and welcome back to e-sipnayan. For today's video, we are going to discuss the introduction to sampling theory. But before we proceed, do not forget to hit like and subscribe so that you'll get notified once we upload new videos. The learning objective for today is for you to be able to distinguish parameter from statistics. We first recall what statistics is all about, and it can be trimmed down to three phrases. First, statistics is all about data collection. We gather data or we collect data for us to be able to analyze it and for us to have an interpretation so that we can contribute to new knowledge to certain field. Now, there are two types of statistics, particularly descriptive and inferential. Descriptive statistics mostly talk about describing data sets. And some examples would be measures of central tendency and measures of variability. For the inferential statistics, this is the part where we are going to infer from the data collected and analyzed. Let's talk about the terms you need to remember when we talk about statistics. And one of the most important terms you need to remember is population. It is denoted by capital letter N, and it simply pertains to the total, or the totality of observations or elements from a set of data. Keyword here is total. So say for example, we have here the whole population of the Philippines. We are talking about a total. What is our elements? The number of people or number of citizens in the Philippines. For the sample, it is simply a portion taken from a population. So say for example, we are going to select our elements or some people, Filipino citizen, from the population. That is now what we call a sample. Now, sample is obtained from the population and it's only a portion of the population. In statistics, it's not always possible to accommodate all the elements in the population in making researches. That's why, in some cases, we are using a sample as representative to the whole population. We are going to learn later on how is it possible to only take a sample and generalize for the whole population. So, for now, your key takeaway here is that population is the total, and sample is simply a portion taken from the population. In terms of symbol, population is capital N, sample is small letter n. Other examples of population or sample: population, all students in San Beda University. We can see here the word all, which pertains to a total. What if we only want a sample? We only take a portion from the population. So say for example, out of the total number of students, you're only going to randomly select 50 students. Now that is the sample. Another example for population, all Bedans in Quezon City. Again, the word all is present pertaining to total. Sample is randomly selecting 100 Bedans. Another example for the population, all Pugs in Visayas. We also again have the word all. And if we only want to take a sample, we select 20 Pugs from Visayas randomly. So in other words, population pertains to a total. Sample is just a portion from the population. Now, in terms of a numerical description, we have each for population and sample. For population, we have the so-called parameter, and it simply pertains to the numerical description of the whole population. So if you want to give a description for the population, then we can assign a numerical value that will represent the population. For the sample, the numerical description or the numerical measure is called statistics, and it pertains to the numerical measure that describes the sample. So basically, parameter and statistics are both numbers or numerical measures describing the population and the sample. So again, the first four terms you need to remember are population, sample, parameter, and statistics. So parameter and population both starts with P. They are the related terms, whereas sample and statistics both start with S, and they are related as well. Now let's practice identifying statistics and parameter given an information. The Food and Nutrition Research Institute of the Department of Science and Technology surveyed 14 million Filipino adults aged 20 and above and determined that 80% of the Filipino adults are at risk of hypertension. Now, to be able to identify the parameter and statistics, we need first to know what is our population. What is the total elements that we are pertaining here? It says here that they surveyed 14 million Filipinos. This 14 million Filipinos is our sample, taken from the whole population of all Filipino adults. So basically, when we talk about population, we are generalizing. So the population would be all Filipinos that are adult. If we want to make it more specific, adult age 20 and above. If we talk about the sample is here. It's explicitly shown. So the sample is 14 million Filipinos. Now, how are we going to identify the parameter in statistics? The parameter would be the numerical measure of the population. It's not explicitly stated here as the sample is given instead of the population. But given the description of the sample, we can now already identify what is the parameter. So what are we measuring here? That is the question. So any numbers you can see as a description can be your clue. So this is the sample. How many did they survey? 14 million. This is just another description, age 20 and above. And this is what they found out. They found out that 80% of Filipino adults are at risk of hypertension. So we have here a numerical measure which is 80%. But this 80% is the result from the survey, from the sample, and not the population. But through the sample numerical measure, which is the statistics, we can identify what is the parameter. How? By generalizing what is this numerical measure. So in terms of parameter, it is simply the percentage of adults' risk of hypertension out of all Filipino adults aged 20 and above. So this is in terms of percent. What is this all about? It is the percent of Filipino adults at risk of hypertension. This is our parameter. This is the one measuring the population, which is all Filipino adults aged 20 and above, which is similar to what we have identified a while ago. In terms of the statistics, it's more explicitly shown here in this information because we're talking about the sample and its corresponding numerical description, which is obviously 80%. So the statistics is the percentage of 80% obtained from the sample of 14 million adults. Now, this is a format of how you can identify what is the parameter and what is the statistics. To be able to state what the parameter and statistics are, you simply try to describe the numerical value. If there is no exact number given, then you generalize. Then you also need to include what is the population and the sample. So notice here that the parameter has no explicit number given, but it is only described through percentage. We know that percentage will be having a corresponding number later on. For the statistics, it's 80%. It's given. Obtained from the sample of 14 million adults. And that is how you identify parameter and statistics. Let's have another one. A researcher wants to estimate the average death age of Filipino women in the last decade, and from a sample of 100 deaths, he obtained a sample mean age of 73. So again, we are going to identify what is the population. If we can be more specific, then better. Because obviously, in all researches, we are specifying our parameter. So for the population, we are talking about what numerical description? We are talking here about age. Age is something that is quantifiable. And that is what we are going to talk about here. So what are we talking about? We're talking about the age of what? And that answers the population. Okay, so the age of Filipino women in the last decade. So we can make it more specific by stating that the population are the Filipino women in the last decade. In the last decade. Obviously, these Filipino women that we are talking about here are those who died, who are already died or deceased. We can say it that way. So we can make the population very specific based on what's given. So that is our population. And what are we talking about here? Obviously, we are talking about their death age. So the parameter is the mean death age taken from the data including all Filipino women who died in the last 10 years or who died in the last decade. So the parameter is described as the death age, but more specifically, we're talking about the average here. So note that average is the same as mean, so we can state the parameter as the mean death age. And what is our population? All Filipino women who died in the last 10 years. Now, talking about statistics, our sample is obviously stated here, sample of 100 deaths. And what is the characteristic or the numerical characteristic of the sample? We're talking about a sample mean age of 73. So the statistics is the mean age of 73 identified from 100 sample. You can state it this way or any variation of this. And that is the parameter and statistics. Another one, Cavex is a drug used to treat patients with metastatic breast cancer. An oncologist wants to determine the proportion of patients taking Cavex who are healed within 10 weeks. A random sample of 300 breast cancer patients was selected and 250 of them were healed after 10 weeks. So what is our population here? Basically, there's a test being conducted and we are talking about patients. But what specific description of patients? We need to identify it in the problem. So it should be breast cancer patients. That will be our population. And from that population, we are taking 300 sample. So a sample, a random sample of 300. Now, what are we measuring here? We are measuring here what the oncologist wants to know, and that is to determine the proportion of patients taking Cavex who are healed within 10 weeks. Now, that is very specific. So, in stating the parameter, we can simply state it as the proportion of patients healed by Cavex within 10 weeks out of all the patients taking it. Now, what is the numerical description? A while ago, we have percent. And aside from that, we also have the mean or average. In this case, we cannot see mean, average, percent, or whatsoever, but we can see a proportion. Proportion is a numerical description, if you can still remember what proportion is. Proportion is simply like a ratio. Now, in statistics, it will be the proportion, which is 250 out of 300. Simplifying that, we'll get 0.833 obtained from the sample of 300 patients. So, this is our parameter and statistics. Another one, the mean height of all students in a Montessori school is 35 kilograms. A researcher wants to validate the results, so he took a random sample of 100 students and got a mean weight of 34.7 kilograms. So we are talking here about all students in a Montessori school. So this will be our population. So from the population, how many sample was taken? A random sample of 100 students were taken. So this is obviously our sample. What are we describing in this population and sample? We are talking about the mean weight. So the parameter pertains to the mean weight of, now it's very much clear what the mean weight is because it's stated in the first sentence. So we can say that the parameter is the mean weight of 35 kilograms obtained from all the students in the Montessori. Meanwhile, for the statistics, we are talking about another value or the sample weight, 34.7 kilograms obtained from a random sample of 100 students. Now, this is the case where the parameter is obviously specified in terms of numbers, unlike the first few examples wherein we describe the parameter in terms of percent, proportion, and mean, the word all.